3 hard, complex fractions that you need to simplify that are going to show up on your test. That, ladies and gentlemen, is what I want to cover in this video, because we all know when your teachers are teaching simplifying complex fractions, they're going to go over the basic ones in class. And then on your homework, they'll maybe throw in some ones that are maybe a little bit more difficult, and maybe on your quiz as well. And then your test comes or the final exam comes, and they're like, bam, here you go, do this one. And you're like, what happened? Like, this is nothing that you taught before. Like, where did this problem come from? Right? And we've all heard it, even as a teacher, I got it. So I guess you can rope me into, that lesson as well. But the important thing about these problems is they're really not that much more difficult, but they do add some layers on complexity to really test to make sure you understand everything we need you to understand for simplifying complex fractions. Now, you can see in this case, there's a lot going on, right? And I don't want you to look at a problem like this and be like, oh my God, this is so confusing. I don't know what to do. Let's stop, take a breath and say, all right, I see a lot of quadratics. I see some polynomials. The first thing that Mr. McLogan would always tell me to do is to go ahead and simplify. Now, to do that, you'd probably want a separate sheet of paper. Now, I don't have a separate sheet of paper, so I'm just going to kind of draw them down below, and then we'll continue the problem after that, all right? But what I want to do is say, all right, all of these look like they can be or should be factored down. And typically, if I had more room on my board, I would just write them in there. Or if I was working on a separate sheet of paper, I would do them right there. But in this case, I am just going to do these like here and try to fit them in the best I can. So negative 2x squared plus 5x plus 12. Scrunch it right in there. Okay. So let's go ahead and factor these down. 4x squared, hopefully you recognize that's a difference of 2 squares. So I can factor that into a 2x minus 1 times a 2x plus 1. Over here, I recognize I have a common x. So I'm going to factor out that x. That's going to give me a 3x squared minus a 6x minus a 24. Now here I can factor, I can factor out a 3x. Ms. McLogan, I always want to factor out the greatest common factor, right? So let's factor out that coefficient. We don't want a coefficient. That makes factoring a little harder. So if I factor out a 3x, that's going to give me an x squared minus a 2x, and therefore that's going to be minus an 8. Okay, then I can factor that down, looks like to an x minus 4, x plus 2. So I have a 3x times a x minus 4 times an x plus 2. And again, like if you struggle with factoring, ladies and gentlemen, you're going to struggle with simplifying complex fractions. That is why factoring is such an important process to be able to do. Okay, so if you want some more examples of factoring, make sure you go ahead and check out my description. I'll add some extra videos in there for you to get practice at this. Over here, I have a common factor of 3, so I'm going to factor out a 3. When doing that, I get a 4x squared plus a 4x plus 1. Here, I recognize that to be a perfect square trinomial, so that's a 2x plus 1 times 2x plus 1, which I can rewrite as a 2x plus 1 quantity squared. And then over here, I don't have a common factor in terms of my integers as far as my coefficients, but I don't want to factor with a negative in front. So I'm going to factor out this negative, and that's going to leave me with a 2x squared minus a 5x minus a 12. All right. Now I need to be see, all right, what two numbers here are going to, can I multiply in this case to be able to figure this one out? And I need to multiply by, so I know I can be a factor of 2x as well as x. And I'm just going to do a little math in my head to figure this out. And I'm going to think of the numbers. Let's start with 4 and 3. If I do 2 times 4, that's 8. And then a 3 minus a 3x and an 8. Yeah, 8 and 3, that should work. So if I do a minus a 4, will that fit? Yeah, minus a 4, and then this would be a plus 3. And let's just double check. That becomes a negative 12, right? So that's negative 8x, that's a positive 3x, which is a negative 5x, and we're good to go. Okay, so now what we're going to do is let's write everything back out in our factored form, okay? So this is like my little sidebar that I did, which I do on a separate sheet of paper. And again, you could do some of this in your head or right next to this problem. Just for like teaching purposes, I didn't want everything to look like so crowded, so that's why I separated it. But let's go and rewrite everything again. So at least in factored form. Actually, you know what? Before I even do it, let's skip a step. What I want you to recognize in this problem is I have a fraction divided by another fraction, right? So guys, it's like a over b fraction divided by like c over d. What do we know about dividing fractions? If I have a fraction divided by another fraction, I can simply rewrite this as a over b times d over c. So let's just go and skip right into that, rather than showing you guys like multiple steps and taking forever on this problem. Let's go and write it in this format, right? So my numerator is going to remain the same, and I'm going to write it in my factored form. So I have a 2x minus 1 times a 2x plus 1. Okay, and my denominator is going to remain the same here, which is a 3x times x minus 4 times an x plus 2. And I'm going to multiply that, though, by the reciprocal here. So again, if this is the denominator here, it's now going to become my numerator. So it's going to be a negative 2x plus 3 times a x minus 4. And then my new denominator is my old numerator up here, which is this factored form, which is going to be a 3 times a 2x plus 1 quantity squared. Okay, now remember, 2x plus 1 quantity squared means 2x plus 1 times a 2x plus 1. So now that we have all of these expressions in these parentheses, these are all separated by multiplication. All separated by multiplication. And remember, when we have things separated by multiplication, we can apply the division property, right? We can find terms or expressions that are exactly the same in my numerator as well as my denominator, and then divide them out. So you can see here I have my x minus 4s. Those can divide out because, again, everything's separated by multiplication. And then over here, I have 2x plus 1, and then this represents 2 of them. So I'm just going to cancel out my squared. So therefore, I just have a 2x plus 1 remaining over. And ladies and gentlemen, that's it, right? That's really all we can simplify in this case. So now I'll rewrite my final answer as a 2x minus 1, or it's a negative, right? So negative 2x minus 1 times a 2x plus 3, all divided by a 3x, or sorry, that's a 9x, right? Because 3 times 3 is 9. So that'll be a 9x. And then I have a x plus 2. And then I'm going to multiply that by a 2x plus 1. And then if we want to talk about excluded values, we can say x cannot equal, what are all the values that make it equal to 0? Now here's where factoring can come so helpful. Guys, you want to find the values that make a denominator equal to 0 of your original problem? No, you want to look at the factored form, right? And we only care about our final answer as well as the denominators that were from our original, which was this one as well as this one. So let's go and figure out what are the values that make these denominators equal to 0 and see if there's any more we can add. We know x cannot equal 0, right? That makes this 0, which is again a denominator. It cannot equal 4 and negative 2. And then from this one, if you were to set each of these factors equal to 0 and solve, you get a negative 3/2 and a positive 4, which we already have, so we don't need to duplicate that. So we have a negative 3/2. And then let's look up here. Is there anything else added? Yeah, well, we already have negative 2. We already have 0. But then over here, we have this 2x plus 1. So we can add this now to a negative 1/2. And whew, there you go. Well, that would be the problem on your test. You can see it's quite a bit of work, right? So let's look into one, though, that might require a little bit more work, but not as much factoring, okay? Because I think we covered the factoring. I got to include one of those. But sometimes your teacher will just get a little unique. Sometimes your teacher will just get a little, what is the word I'm thinking for? Not unique, but creative with just kind of pulling together different denominators, but not really dealing with so much factoring work, okay? So here we go. We have one fraction in our numerator, and then we have the difference of two fractions in the denominator. Now, when we have this complex fraction like this, we want to get rid of our denominators. Specifically, we want to get rid of this x cubed, x squared, and this x cubed minus x squared. We want to find the largest polynomial, or sorry, not the largest, the smallest polynomial that all of them are going to divide into. Now, we know they divide into themselves, right? So, but we need to be able to figure out, like, what is this commonality that they have, what we call the common denominator. Now, the first thing I want to look at is this x cubed minus x squared. Always look to see if something can be factorable. And if it can, then factor it. So x cubed minus x squared, I can factor out an x squared. And when doing that, I'm going to get a x minus 1. Ah, this is important. So now I know that x squared is going to divide into that, but x cubed does not divide into x squared. So when I'm talking about, or I'm identifying my LCD, ladies and gentlemen, my LCD needs to include at least a x to the third power, because this has to divide into it. X squared will divide into x cubed, but then also I got to have this x minus 1 divide there. So I need to include a x minus 1. Now, the reason why the LCD is so important, because when we multiply every single expression by this LCD, our denominators are going to divide into it and eliminate it. So let's go ahead and multiply here a x cubed times an x minus 1. And I'll just kind of move this over to the side so I'm not like overly confusing people. This was just us identifying it. We'll put it right there. Okay. So what I'm going to do is I am going to, where are you? There you are. So what I'm going to do is I'm going to multiply this times this numerator, this fraction, and that fraction. I'm not going to write it out because I don't want this video to take so much longer. Actually, you know what? I'll do this for this one. I always have to do it. I don't know. You know, it's like one of my pain points, I think, when I was a student in school was the teacher would always skip over steps. And whatever steps they skipped over, that was always the step that I would get confused on, right? And it was just like the most annoying thing. And I didn't understand why it was, and like sometimes I would understand why they skipped over, especially now as a math teacher. I'm like, why am I going over this extra step? Like half the students understand it. But the thing is, for the students that don't understand it, it's because you just skipped over a step to save time. And I'm saving a little bit of time. I'm saving a little bit of work. But I think it's really important to understand that we're applying this distributive property. We're multiplying the LCD. We're creating equivalent fractions. So whatever you multiply in your numerator, you have to multiply in denominator. And since your denominator is separated by subtraction, right, you can think of that as parentheses. You got to apply distributive property. So it's just really important to make sure when you're multiplying everything by your LCD, multiply everything. And especially multiply your numerator and your denominator. And then especially if your numerator or denominator is separated by addition or subtraction, you have to distribute to both of those terms. Okay. All right. So now to clean everything up, I'm going to rewrite this now, and I'm going to rearrange this. I don't like how this is written, the 3 minus 2x. So if I write that as a negative 2x plus 3, when I multiply this times that, I'm going to factor out the negative, and that's going to leave me with a 2x minus 3. I still need to multiply it times this x minus 1. And then also remember, there's an extra x here, right? So 2x minus 1, did I mix that up? Oh, that's supposed to be an x cubed. No, those divide out. Oh, that was over there. Okay. That 2x minus 1. And then over here in my denominator, I'm going to have a 2x, right? Because that's a 2 times one of these x's times an x minus 1. And then over here, that divides out. So that's going to be minus 1. Okay. All right. So now let's go and see what this is going to be. Just go ahead and apply a little bit of FOIL or distributive property, however you want to think about that. I'll expand it out. We'll leave this all in negative. I'll leave the negative on the outside here. So that's a 2x squared minus a 2x minus a 3x plus 3. And then over here in my denominator, that's going to be a 2x squared minus 2x minus 1. Okay. And then just remember that's a negative, so we got to distribute that one more time. And when I distribute that, I'm going to get a negative 2x squared. Let's see, that's a negative 5x. 2x minus 3x is a negative 5x, but times a negative is a positive 5x. And that's minus 3 divided by a 2x squared minus a 2x minus 1. Whew. Okay. And 2x minus 3 times x minus 1. Oh, yeah. Yeah. So we can 2x minus 3, that's going to be negative 5x. Gotcha on that negative. Why did I distribute that negative? I probably actually want to keep that in that format. The last thing we want to do, though, is check our restrictions. Okay. Now, the important thing when checking our restrictions on this example, you could factor this back out. Actually, and if you look at this, let's see if we can factor this denominator, right? Can I factor this and simplify this in any other form? Or is there any other values that would make this equal to 0 that are not going to be extraneous, right? So this is very, very important because right now I'm looking at this. I'm not sure, is this going to be factorable, right? And you could leave this in our factored form if you want to, but let's go and take a look over here. Could I factor this as a 2x times something times an x times something else? Now it has to be a negative 1 and a positive 1, but it doesn't look like, guys, I'm going to get I'm going to be able to factor this. So the next thing I'm going to do is check our quadratic formula. First I'm going to check the discriminant. So it's going to be, that's going to be b squared minus 4 times a times c. And again, if this is negative, then there's no real values that are going to make this equal to 0. So what I'll have here is a b, which is in this case, so it's a negative 2 quantity squared minus a 4 times negative 2 times a c, which is a negative 1. So negative 2 squared is going to be a 4, and that's going to be a positive 8 So negative 2 times 8 is a positive 8 times 1, so that's a negative 8. So that equals a negative 4. The reason why this is important, that's my discriminant. That means my denominator has two real complex solutions. Or I'm sorry, not two real. It has two complex solutions. So there's no real numbers that's going to make this equal to 0. So I don't need to worry about adding a restriction here for the simplified answer, okay? And since it's not factorable, I know that it's not going to be able to divide any more terms out if we are looking into simplifying it. But I still need to include my restrictions that I had for the original problem, okay? And that's where a lot of students, again, will get stuck up. So x cannot equal, let's go back to our original denominators. We have 0, and then also we have 1. X cannot equal 0, and x cannot equal 1, okay? But again, there's a reason why this is a great test question. A lot of students will not check this, or sometimes we'll throw in a quadratic that you could find irrational solutions for, and you'd have to restrict those, okay? And that's why this is a good question to check. All right, let's get into the last test question, and hopefully these examples are helpful for you, because I understand simplifying complex fractions, they can be difficult. And then usually students, once they start to get the hang of them, it only takes a couple little tweaks for them to feel like they get confused all over again. Okay, so that's why I wanted to kind of cover as many different variations that you could expect on your test. So therefore you don't end up getting confused as well. So let's look at this last one, which is going to have a lot. It's not hard factoring. It's just dealing with a lot of extra work. Okay. So again, when I see quadratics, ladies and gentlemen, I immediately just tell my students, or I want you to think factor, 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 factor. Okay. So over here, I can factor this into a x minus 1 times x minus 1. And you could write that as x minus 1 quantity squared, but I think it's sometimes easier visually to see your common denominator or your least common denominator when everything's expanded. So I'm just going to leave it like that. Over here, I see I can factor that into a x minus 2 times a x minus 1. Over here, I wrote that wrong. Sorry about that. That's supposed to be a 4. So over here, that's a 4. So I can rewrite that as a x minus 2 times an x minus 2, right? X minus 2 quantity squared. And then over here, I can write this as a x minus 2 times a x plus 2. Okay. So now at this point, if we want to look into identifying the LCD, it's going to be kind of complicated. Okay. Now I will write out the LCD for you and you can kind of see, but I'm going to show you a different way to approach this. And again, on a test, you can go through the LCD method. It's perfectly fine, but I want to show you a way that we can simplify this or apply this problem, hopefully in a little bit easier fashion. So I have my LCD has to include an x minus 2 times x plus 2. So I have an x minus 2 times an x plus 2. All right. And then I have to include this x minus 1. But again, I got to have both x minus 1s, x minus 1 and x minus 1, right? They're x minus 1 squareds in that denominator. So I have to square that. And then over here, I have 2x minus 2. So that needs to be squared. So I have her there. So yes, you could multiply your LCD times all of these terms. And ladies and gentlemen, that could sometimes get to work and there's going to be a lot of mistakes made. Another way that I want you to think about this is, again, often when we're teaching simplifying complex fractions, yeah, you can multiply everything by the LCD, which is my favorite approach on majority of problems. However, you can also combine your rational expressions in the numerator, combine your rational expressions in the denominator. Then you'll get a fraction over a fraction, which like in the first example in this video, you can just reciprocate and multiply. And sometimes that's an easier approach. And that's the way that I'm going to do this one, because if I want to get common denominators over here, recognize all I need to do over here is to get an x minus 2 times an x minus 2. Over here, to get common denominators, I just need to multiply by an extra x minus 1 times an x minus 1. Over here, again, let's strike through these. Over here, if I want to get common denominators, this is an x minus 2 times x plus 2. So to get over here, I just need an extra x minus 2. Just an extra x minus 2. And then over here, I have an x minus 2, x minus 2. I just need to multiply by an x plus 2. Okay. I think in this case, it might just be a little bit easier. Now let's go and multiply everything out. X minus 2 times x minus 2 is going to be an x squared minus 4x plus 4. And that's going to be plus a distributive property, right? X squared minus x. Now again, that's going to be over my common denominator of x minus 2 times x minus 1 times an x minus 1. You can write it simplified. Again, I just like everything factored form until I'm done with it. And then Over here in this denominator, I'll have x times x plus 2. So that's going to be a x squared plus a 2x. And then that's going to be minus. Okay, make sure you put minus. And sometimes it's helpful even to add in some parentheses so you don't forget it. Because if you don't put in these parentheses, you'll just subtract the first term. You won't distribute that negative. So a lot of times I like to insert parentheses here. X minus 2 times x minus 2. It's going to be x squared minus a 4x plus 4. Okay, and then again, that's going to be all over this common denominator as an x plus 2 times x minus 2 times an x minus 2. All right, so now let's go ahead and simplify some things, right? So let's see, I have an x squared and an x squared, a negative 4x minus x, which is a negative 5x, and then plus a 4. And then over here, I'll have to just distribute that and combine like terms. Let's actually negate this. So if I negated this, it'd be a negative x squared plus 4x minus 4. Okay. And then I can combine these two. That's going to go to 0. And then combine these two. So 2x plus 4x is 6x. And that's it. All right. So let's simplify this. It looks a little crazy. So x squared plus x squared is a 2x squared. Negative 4x minus x is a negative 5x. And that's going to be a plus 4 divided by x minus 2. Oh, actually, you know what? Yeah, x minus 2 times x minus 1 times x minus 1 divided by this fraction here, which is a x squared minus an x squared. So that's 0x squared. 2x plus 4x is going to be a 6x and minus 4. And that's going to be all over this common denominator of a x plus 2 times x minus 2 times x minus 2. All right, now again, if I'm going to be factoring these, or I'm going to taking this fraction divide another fraction, I want to see, is this factorable, right? Can I break this down? Let's go and do that real quick. Can I take a 2x and then multiples of 4 here? So I could do 2. So 2 times 4, or 2 times 2, no, it's going to work. 2 times 4 would be 8. And then times 5 times 1, that'd be, no, that's not going to work. So this is not going to be factorable. So that's not going to divide out with anything. But now let's just go ahead. But here, I can flip out a 2 here. And if I factor out a 2, that'll leave me with a 3x minus 2. 3x minus 2. X minus 2 times x minus 2. Yeah, okay. All right, so now, again, we have a fraction divided by a fraction, right? Again, when you're taking a fraction divided by another fraction, you flip and reciprocate. So what I have here is a 2x squared minus 5x plus 4, which is non-factorable, divided by a x minus 2 times x minus 1 times x minus 1. And then I'm going to multiply by the reciprocal here, right? So that's going to be a x plus 2 times x minus 2 times x minus 2 all over a 2 times 3x minus 2. And then look at, I got something. Yes, that's what you always want to look for, right? For all this work for one expression to go ahead and divide out. Man, what a crock of a problem, Mr. McLogan. But ladies and gentlemen, that's it. So 2x squared minus 5x plus 4. And that's going to be times a x plus 2x minus 2. So I could write that as an x squared minus 4. Or you could write it in factored form, which I would prefer as a teacher. Or you could multiply it out, whatever your teacher, instruction is. And then you have this as a factored form, x minus 1 times x minus 1, which is x minus 1 going squared. Let's put the 2 over here. And then a 3x minus 2. Okay, not necessarily the exact proper way to be able to write it out. Again, it's all going to be dependent on your instruction. But again, let's go back through our restricted values. X cannot equal. Okay, what are the values that can make it equal to 0? 1. If you take 3x minus 2 set equals 0, that'd be a positive 2/3. Okay, that it can't equal 0. 2, no. 2 is not an excluded value. 2 does not make the denominator equal 0. There's just a constant here too. That's it. But then we need to go back to our original equation. Over here, 2 makes that a denominator 0. So that can't work. We have 1. That can't work. And then also a negative 2, right? Negative 2 would make this denominator equal to 0. So we can't have 2 or negative 2 as well as a positive 1. We can't have a positive 2/3. And there you go, ladies and gentlemen. Good luck on your test. Now, if this was kind of a little over your head and you want to look into some more examples where I cover popular types of questions that you absolutely need to know, or if you're really like struggling and just starting out, then I also have a video linking here for you to get started with simplifying complex fractions. So hopefully this video was helpful for you guys. If it was, then go and check out the next video I have for you here. Cheers.